Hello, welcome everyone here. My name is Tima Laszlo. I'm from Nokia Cloud Band, and here with my colleagues we will speak about some cloud-native VNFs and how we imagine a hybrid setup. So Dr. Liat Pele and Ruven Milstein will speak with me together. I will start with some introduction, and then the experts will explain a lot more. So thanks for coming. First of all, before going into the details, I'd just like to be sure that we are on the same page when discussing the terminology. So I'd like to define how we at Nokia understand microservices and containers and what we think behind them. First of all, what is a VNF? So VNF is a virtual network function. It's basically an application which is running on top of a virtual environment like a cloud or a container-based environment. So it's an application, but I will refer to them as VNFs because that's a telecom terminology. Normally, these VNFs or applications are huge monolithic ones. So their components are tied together, they'll build together. If you want to change some tiny portion of it, you need to change the whole. That can be very painful. That's why we are already started years ago to move towards microservices. So actually splitting the functionalities of the application or the VNF into smaller pieces, which are loosely coupled. They are usually communicating via well-defined APIs and open interfaces. So it means that if the development team, which is responsible for a component, wants to use a different technology, a different programming language than the others, it's possible to do that. They have the freedom. It's possible to deploy these microservices into containers. We will define it in the next slide, what is that. I'm sure that everyone knows, but just to be sure. And similarly to the virtual machines, it's also very easy to distribute these containers and smaller components on a distributed setup, so different hosts, different hardware. And also, which is very difficult topic in case of applications. I mean, huge applications, the configuration and the logging of these components are very flexible and customizable. So again, microservices are loosely coupled components of the application communicating via well-defined APIs, and they are self-contained, they are independent from each other, and they can be deployed into containers. What are the benefits? Just like we already mentioned, compared to the monolithic ones, that, for example, upgrading an application is much easier. So if you think of a security patch, it's usually a small piece of a hardware, program, and it affects only a small component of the whole application. And if you need to change or upgrade the whole VNF, then it's quite painful. So in case of microservices, it's much easier just to change only that small portion. The deployment is also simpler in this case. Scaling of these services is much easier. They are by default designed for scalability. The software architecture is more flexible in this case, as just like we discussed, that you can select different programming languages for different components. So we really think that this can speed up the telecom development in this case. Okay, so back to containers, what we mean behind them. So I know there are several technologies, but we think that at the moment, the de facto tools for containers are Docker, so which is the engine, and Kubernetes. Just to define them, these are copy-pasted from the docker.com, so it's nothing reinvented. I'm sure that everyone is aware, but just to recap, if we compare the containers to the virtual machines, the basic difference or the main difference is that it's a little bit more lightweight. So what is encapsulated in this case is basically the application code and some libraries, but not the operating system. The operating system is shared, and this is the Docker engine which will make it possible. So that will enable to share the operating system between these containers. So they are portable and yeah, a little bit smaller. And Kubernetes, so this is a higher layer on top of the Docker engine, and this is basically an orchestrator for the container-based applications. It provides basic deployment, scaling, and some other management functions for the containerized applications. So Docker is the engine, which helps you run the containers, and Kubernetes is the layer which orchestrates the containerized application. And we believe, again, that these are the de facto tools at the moment. I know there are some others, but we study these ones. And to define what we mean via hybrid environment, it's not hybrid in a way that we are linking private and public clouds, but in a way that let's imagine that we have a hardware pool in the customer environment, and they might decide to go bare metal, which means that in that case they will install the container engine, for example, the Docker, directly onto the host, onto the hardware. They will install on top the Kubernetes, which is, again, the orchestrator. And just like we discussed, the VNFs are decomposed into microservices, and those can be deployed into containers, and those can run directly on these hosts. So in this case, there are no hypervisor. They are running directly on the hosts. The other way around is that, for example, if we have a cloud setup, for like OpenStack, and we define or we create virtual machines in the cloud, and we consider them as hosts, virtual hosts for the containers. It means that we can install the Docker, so the engine, in a shared way on these VMs, like on normal hosts, install the Kubernetes on top, and deploy the containers of the applications directly into the virtual machines. So the difference is, in the bare metal case, we run them directly on the host, and in the virtual machine or the other case, we run them in virtual machines. But in this case, these virtual machines are like hosts to the application. And this is what we refer to as hybrid environment. And my colleague Liat will explain to you which one is better in which case, so whether bare metal or whether the virtual machine based, and why is it good to have maybe both in the same environment.
Can you hear me? Okay. So one of the questions that is frequently asked is, what is better, to have the containers over VM or the containers over bare metal? There are advantage and disadvantage to each solution. For example, if we have when we have large lab with thousands of nodes, we would prefer them to be the same. So when we have VMs, we can have like another virtual layer, and then if we need to upgrade or update, then everything is the same. When we use VM, we surely have tenant separation. Although in containers we have this policy, network policies, still in many cases, people more trust the staff tenant separation of the VM. The benefit of running over bare metal is that performance is, of course, the best. They have a smaller footprint, and in some cases, like when running a machine learning algorithm, we may want to use the GPU that is in the bare metal. In some cases, we may maybe even want to use both of them. So some application will run on the bare metal and some on the VMs. When we consider the performance, the most important performance that we need to consider is the networking. The CPU is almost not affected from running on a VM. The networking is, it has two parts. One is the networking between the container and the VM, and one between the VM and the host. The most important is, of course, between the VM and the host, because the container is the same in both cases. In this case, if we have OVS layer, then we need to do another calculation in each time a packet goes from the VM outside. But this can be improved if we use SRIOV and DPDK. And we see that it's almost the same performance like bare metal. Now, Reuven will talk about bare metal provisioning.
Everyone can hear me? Hi. I'm going to talk about hybrid system, which means virtual machine and bare metal instances. As we know, over cloud, OpenStack have the ability to create and deploy virtual machine with Nova service, but we also have an opportunity to create and deploy bare metal. This is done by Ironic service. So what is Ironic service? Ironic service is a project under OpenStack umbrella, which aims to provision bare metal instances instead of a virtual machine. There are some challenges when we deploy bare metal instances. For example, there is the networking issue. The provision network of the bare metal should be like the controller. It means that in any case, some tenant can destroy the controller because you have a shared network like the controller. And there is also the security issue because we don't want that the customer have the same network of the controller. And the last one is a long time until the bare metal is ready, right? VM take a short time, but when we deploy bare metal, it takes, I assume, 10 minutes. So this is something we need to take to the account. Okay, this is the flow of bare metal creating. The first step is enroll the hardware. Which means we need to give to the Ironic API a YAML file that describes the information of the bare metal. I have an example here. So this is the YAML file. As we can see here, this is the name of the node, node 0. The driver we are using, it's a IPMI, and the IPMI address, the username, password, the properties of the instance, like the CPU, memory, and of course the Fuxi NIC MAC address. Okay, so we have a bare metal instance. Now we want to create a network between the bare metal instance and the virtual machine and the container on top of them. So there are too many players in the market. One of them is Flannel. The second is Kuryr. Kuryr is a project under OpenStack umbrella. And there is also the Calico. The difference between Flannel and Calico is that Flannel working with encapsulation, which means layer 2 on top of layer 4. The performance of Calico is much better than Flannel because Calico is working like layer 3 connectivity, which means that every host, it doesn't matter if it's a virtual machine or a bare metal, acts like a router. You work with a BGP protocol. The router advertises the routing table of himself to another neighbor in the autonomous system. And in this way, the container can communicate with the other container it's very important. Okay, so for me, it's very easy to deploy the Calico networking. I'm going to show the demo. The demo is about creating a container over bare metal. The demo flow is that we have two instances. One of them is a virtual machine, and the second is a bare metal. Then we have the Kubernetes system, one master and one workload. The two instances is related to OpenStack infrastructure. Then I will show the Calico as CNI. CNI is container network interface. Then I'm going to create Nginx pods and service to expose them. And I'm going to enable the security group. And after that, deny any traffic from that pods. Okay, as we can see here, this is the OpenStack horizon. We have two instances. One of them is the master, and the second is worker one. The master is bare metal instance, and the worker one is virtual machine. I'm going to demonstrate you that the master is really bare metal by logging to the master. Now I'm in the master. I'm using the command lshw. As we can see, the product is SLG7. It means it's really bare metal. Now I'm going to Kubernetes dashboard. In Kubernetes dashboard, we can see that we have a pods under the namespace kube system. The pod is Calico pods, so the CNI is Calico. Also, we can see the nodes. There are two nodes, worker and master, which OpenStack deploy for the cluster. Now I'm going to create the Nginx pods and the service to expose them. Before that, I'm going to create the policy demo namespace. Done. Now I'm going back to Kubernetes dashboard. As you can see, the namespace policy demo is created, and the pods Nginx are also created, and the service, of course. Now I'm going to create a client pod. The client pod is based on image BusyBox. And from the client pod, I'm going to pull any information from Nginx pod. It will be the default page of Nginx pod. This is the IP of the Nginx pod. Now I'm in the container using the command wget with the IP, of course. And we can see the page. Welcome to Nginx. Okay, cool. Now I'm going to repeat the demo, but I'm going to deny any traffic by using the security group of Calico. It's a YAML file. As you can see, the kind is network policy. API version is networking Kubernetes, metadata, default deny, the namespace policy demo, what we already create. And now I'm going again create a client pod, open and enter to the client pod, of course, and then I'm going to try the wget command again. And surprise, you will not see any traffic, due to the fact that we enable the security group and deny any traffic. So what we saw in this demo, we saw two instances, combination of instances, virtual machine instances, and in the first time, Ironic created bare metal for the tenant. Many people ask me why to create a bare metal virtual machine is not enough. In most cases, I agree, but we have flexibility to choose any machine we want. The customer can choose to work with bare metal or with virtual machine. It's another option. That's all for me.
Monitoring. Hi. These kind of systems are very complicated. And because they are very complicated, many parts of them can mess up. That's why it's very important to monitor. The thing that is need to be monitored is actually everything. We would like to monitor the hardware, or the Kubernetes itself, or the OpenStack itself. Monitor the containers is possible as well. We can monitor the throughput to and out of the containers, and we can monitor the VNF. For monitoring the VNF themselves, the VNF or the service must expose their performance out. The objective of the monitoring would be the CPU and the memory and everything that connected to the network. Every port and every throughput that goes, it's good to be monitored. Okay. Requirement for monitoring system will be, it will be reliable. We don't want to have blind spot. In case we have outrage, we want to know what happened that caused this outrage. We want to be able to scale it to large systems. We want it to be dynamic, especially in case of Kubernetes, where pods are coming and going in different nodes. We must have monitoring and handle this dynamical system. We must have support for data filtering, because having such a big amount of data will cause our system to fail if we don't know how to monitor it, how to take what's important for the data. In our case, we use two kinds of monitoring, although there's a lot of good monitor systems. The first one is Zabbix. Zabbix is designed for servers and agent architecture. It collects and aggregates monitor data, and it has a great alerting system, and it has some predicted event. It can calculate, for example, the trend and see when it will reach some point. It has a QSQL database. And Prometheus is the other monitoring system that is used. Prometheus is 67% of the Kubernetes users use Prometheus, according to Datadog statistics. It has very flexible query language and database that is relative, which means it's very, very powerful for getting the right expression from the data. It has alerting systems, and from my point of view, the main strength of Prometheus is that it has pluggable exporters. Like everyone can take any monitoring system that it has or alerting system that it has and implement exporter that can be plugged into Prometheus. And from the other side, Prometheus can give you alert in any way that you want, almost. So I think that this is one of the reasons that Prometheus becomes so popular. Although 67% of Kubernetes use Prometheus, but most of them actually using another alert system like Advice or other Kubernetes monitoring. But having such a complex system with such a monitoring data that we are collect is not enough, because when you have such amount of data, you get to lose the point where things started to get bad. For that, one must use RCA, some RCA like Vitrage, root cause analysis method. Vitrage is root cause analysis library that is started in Nokia in-house, but now is part of the OpenStack community. It grabs the topology of the systems and alarms and give the user a holistic view of the system and of the problem. It can deduce alarms, it can find the root cause analysis, and organize the alarm and the events. This is example of the root cause analysis view. Here we can see that in case if a process load is too high, then we can have a deduce alarm that rise from this initiate alert. And we can have an alert view of all the alerts in the system. Okay. I think this will be the last slide. I encourage everyone to visit our Vitrage in the booth and see our great demos. And I would like to use the minutes that we are left with discussion and questions. So please, questions. I know we are... Questions? Yes.
If you are using VMs but you wanted to move forward to containers, is there like a migration path, or is there an easy way to move between the two?
If we have a container, if we have a system that we want to have both VM and container and they will talk with each other, well, there's several. The most challenging part of this architecture is how you connect the network between the two parts. There are several solutions to this in the market. If you're using Kuryr, for example, which give you the same using the host network, then you get it almost free because it's the same network. If you use Calico, that is based on a BGP protocol, then you can just get the BGP to talk with the VM. And there's a new project called ISTO, I think. I met them in the marketplace, and they promised that in the next version, they will just do it like magic. Thank you. Any more questions? Questions? Okay, so that's it. Thank you very much.